All right, so we'll go ahead and get started. Like we've been doing for the last couple exercises, today is a lot of repetition. So we'll start at the very beginning this time, and I'll work the way all the way through a finished model for laser cutting. So by the end of what we're doing today, you should basically have all the steps that have been put together so that you can get to your assignment 202 and have that ready to turn in. Remember, we're not actually going to be laser cutting this semester. It's not required. I did find out, though, based on some inquiries that you guys had during check-ins last week, or on Monday, that there are some open lab hours where if you wanted to try to laser cut, or if you wanted to try to 3D print, when we get to that section, we can get you into the lab and have you work with it. There's a guy named Bob Logan who's in charge of the lab, and he has some open times. Generally, if I'm not mistaken, let me pull it up here so I don't misquote it here. I put this on the homepage of Canvas just so you can see it. On Tuesday, Wednesday, and Fridays from around 10 to around 5, he's in the lab, and it should be open, and you can have access to the laser cutter and or the 3D printers. That being said, I would think it would be a great idea for you to email him ahead of time and try to set up an appointment. Ask him, hey, can I come in? I want to try to 3D print or whatever. And so I can walk you through that. Well, obviously you'll have the steps, but if you talk to him, he can actually do it in person, which would be really nice. So I have his email listed on the homepage of Canvas, and also the times in case you lost track of that. There is also tomorrow, the Cal Poly SLO landscape department is having like a transfer student thing, question and answer session. So if you're interested in doing that, I do have an announcement on the homepage so that you can go to that Zoom session and get some more additional information. That's for landscape students who are interested in transferring to Cal Poly. Okay, so we're going to go ahead and I'm going to share my screen, get organized, and then we will go ahead and get started working our way through. I did pull up my file from last class with the steps already on it, but I'm going to start back at the beginning, and then I'll fast forward so you don't have to watch me draw the steps on the sides all the way. But we're going to go through all of it again, just for good repetition. We'll spend the bulk of our time today working on the corners, and then kind of the final translation of how do we make this a laser cut file. So we'll get to that in just a second. But in the meantime, I went ahead and I opened up the SketchUp Pro app on the remote desktop. Here it is. And we're going to get our terrain information from SketchUp Pro. So I'm going to go ahead and delete the little person here. Oh, sorry, I have to right click and say erase to get rid of them. And then I'll go up to the file menu and I'll choose geolocation, add location. And we could get this information from a variety of sources, but for our purposes, we're getting it from SketchUp because it's an easy source and it's easy for us to get. But any kind of a GIS data set we could use and do the same sort of thing with. So I'm going to go back to Lake Tahoe again. And let's zoom out a little bit. And that is definitely not Lake Tahoe. But let's try it again. There we go. And so if we were to zoom in on a particular area, let's say that I like this area right here. At a certain zoom level, I can choose this select region button. And when I select that region, it's going to let me select a piece of land. So let's say that I want to pick that piece of land. I'm going to switch to this digital globe, and then I'll click on import. And there it is. To see it in SketchUp, I'll go to File, and then Geolocation, Show Terrain, and that'll give me the piece of terrain. Sorry, I need to middle mouse to orbit here. So there's that piece of terrain. So at this point, I want to save this into a Rhino compatible format. So I'll go to File and then Save As. And I'm going to go backwards in SketchUp. I want to go back to about 2018. And then I'll give this a name. And let's put it into our folder for today. There's Tahoe 3. Again, 2018 file. I'll go ahead and click on Save.
Why did you change to 2018?
because I'm not sure that Rhino, when you get to the new versions, it's possible that Rhino hasn't updated to read the SketchUp 2022. I know that it reads 2018 and we're not losing any data by doing that. So I just back save it there. We could, let's do it just as an experiment. We could do it and save it as the most current version, and we'll see if it comes in. It's just a matter of which has been updated most recently. So we'll go ahead and save this as its current version, and let's see in Rhino. And maybe it's been updated, maybe Rhino's been updated. Part of it is we're working on the lab computer, so we're not always in the exact current version of a piece of software. So let me open a brand new Rhino file. Let's minimize SketchUp here. I'm going to go to new, and we're going to do a large object inches template. And I'm choosing that because that matches the units that SketchUp was in. There we go. And I'll go up to the file menu and I'll choose file and then import. And like I said, we're going to try out that Tahoe 3-2. This was the most current SketchUp file. Let's open it. Let's see if it loads it. It loaded it. So I guess we can use just the generic SketchUp file. We don't have to back save it. So that's good. That must mean that the Rhino file has been updated fairly recently. So I have, and like you guys can see, I'm moving a little bit faster today through these steps because we've already done it a couple times. So in this, let's go ahead and switch ourselves into our shaded mode. There we are in our shaded mode. And I'm going to organize my layers. So let's create a SketchUp layer. So I'll call that SketchUp. And then I'm going to have an SK flat. And then another sublayer for SK terrain. I'll take the mesh file that's my terrain, put it on the SK terrain layer. I'll take the flat file and put it on the flat layer. And that's just simply right-clicking on the, selecting the object, then right-clicking on the layer. And that'll let me turn off the flat file and work just with this piece. So at this point, I need to convert this mesh into a nice, clean NURBS surface. So this is where those contours come in. So I'm going to rename layer 1 here to be Contour X. So there's Contour X. Let's make it the active layer. So I've moved my check mark down so it's listed as active. In order to snap to the mesh, I need to turn on Vertex Snap. That'll let me snap to this end. And then we'll go ahead and use the contour command. So I'll go up to curve, curve from objects, and then contour. There it is. I'll choose that point right there. And since this is Contour X, I'll turn on ortho and we'll go right in the X direction. Again, not snapping to anything. And then I need to guess what the distance should be. So I always try 100 feet to start, but we'll see if that's too close together or too far apart. It's a little far apart. So let me undo here, and we'll do it again, contour. And let's do that at about, let's try it at 50 feet. It's close enough. Then I need to contour in the Y direction. So I'll double click on layer 2 here and rename that to Contour Y. I'll make that the active layer. And I'm going to contour the mesh. Remember, if I were to contour the contour X's, if I went in and said contour, when I did the contour, I get a bunch of points. Well, we're not interested in the points. So let me get rid of those. We'll come back. We want to make sure that I'm contouring the mesh right there. I'll type contour or do curve, curve from objects, contour. Pick that same point. We're going in the Y direction. We'll do our same distances. And there's my next set. So at this point, I can turn off the SketchUp layers altogether, and I'm left with what will ultimately be a curved network. So it's a network of curves that I can convert into a surface. As we've experienced before, the ends need to be trimmed to be nice and even. So we'll go in and we'll do some trimming. I'll select that, type trim, or go to edit and then trim. Get rid of all our lines right there. Zoom in, make sure I got them all. Yep. And then let me get rid of this line. And then we'll trim this section. And we want to make sure we got them all. Yep, we did. Hit enter to finish and escape. And then I'll go ahead and delete that section. We'll use this line and we will trim again. There we go. Oops, I missed that last little piece. There we go. And then I want to delete that segment. And I'm left with this last piece over here on the right. So this is always the most difficult one to trim because we kind of have to zoom in, and doing the selections is much harder. So we'll get rid of the first couple here manually. All right, and then let's see if we can get them all this way. Missed a couple. And I'm pretty sure I got them all. Perfect. So I'll hit enter to finish. And now I have a nice orthogonal grid that I can use for my curve network. So this is always a good place to save. So I'll go to File and then Save, and we'll make sure we're saving this. This was Tahoe 3, so let's put it in its folder for today. We'll call this Tahoe 3. I'll go ahead and click on Save. And there it is. Now it's time to convert this over into an actual NURBS surface. So let's use our layer 3 here. Let's call that one Terrain. We'll make it active. And then we're going to go ahead and do our curved network. So in this scenario, I'm going to, again, just for ease of getting it done during lecture live, I'm going to select all of the contours in the Y direction, and I'm going to add, by holding down the Shift key, the 2 contours at the ends, there and there. And then I'll go up to Surface Curve Network, or I'll type in Network SRF into the command line. And this is the patience game, so we have to be a little bit patient here. We'll wait for it to show up in all the views. And there we go. We'll go ahead and say OK. And we'll give it some time. And even though this takes time, this is why I always do it live, so that you can see that this is normal. So I think it's possible that it's done. Let's click off and see. Yep, it's done. You go ahead and click on the surface. And when I do that, we get the big yellow block. And now it's time for a rebuild of the surface. So with the surface selected, I'll go ahead and type in rebuild, or go to edit and then rebuild. And I'm going to rebuild this at 100 by 100. And I'll go ahead and say OK. Now I have a really nice surface to start working with. It's reasonably smooth. We could turn off the contour X and Y. And now we can see that nice surface. So that's perfect. So we have our NURBS surface, and it's now time to start thinking about it at a particular scale. So if you remember last class, and actually I'm going to save this while we have it done, I pulled up this cheat sheet that talks about creating a topography model. And we're creating our model at 11 by 17. And so I have to understand what scale I want to create this model at. Now recognize that, of course, sometimes you're given a scale. I want to see a model at 1 to 100, or I want to see a model at a 1/16 inch equals a foot. So you could pick a particular scale, or maybe it's dictated for you. I believe this terrain's a little bit smaller, so it's probably going to be like the 1 to 200 feet. If that's the case, it would be 2,200 feet by 3,400 feet. That would be my rectangle. So let's give it a shot. So we'll create a rectangle at 3,200 feet, comma 2,200 feet. Enter. And there it is. If I look at this in the top view, we can see that, yeah, it's actually still too big. I picked a much smaller piece of terrain this time. So let's delete that one. Let's go back to our file here, and let's do it at 1 to 50. Let's try that. This would be 8,500 by 5,500. So we'll do a new rectangle at 850 feet, comma, sorry, I have to put the feet in, 850 feet, comma, 550 feet, enter. And there's that size. That size would work. So in this example, I can use this size, oops. And now I want to move this so that it's over the terrain. And as I'm starting to think about the terrain, I may want to switch this into shaded mode so I can kind of see where that ridge is and make sure that I'm falling on the ridge nicely. That looks pretty good. Now I need to have that rectangle that's flat projected onto this surface so that I can do a trim on the surface. So in the top view, and it's specifically in the top view, I'm going to select the curve, and then I'll do a curve from objects, project. It's going to ask me to select the polysurface or a surface to project onto. That would be my terrain right there. I'll press enter. And again, I'm doing that in the top view, and it then creates the outline of my surface right there. So at this point, we can go ahead and type trim, or go to edit and then trim, and we can get rid of the rest of the surface that we don't need. Now, at 1 to 50 scale, this piece of terrain will end up being 17 inches by 11 inches. So it's a great piece of terrain there. It's actually pretty steep, so there's going to be a lot of steps on it. I'm glad I'm not actually doing all the steps on this in front of you today. And so now that we have this and it's scaled, let's save it. But we have to start thinking about what are the intervals that we're going to cut this up out of pieces of cardboard. So we need to go back to that topography creation cheat sheet, this one, and we have to know the thickness of our material. So we've been using the 5/32 inch material. That's a standard cardboard size. So at 5/32 of an inch, we're going to come to 1 to 50 scale. We'll come over here. And there it is at 5/32 of an inch. It's 7.813 feet. Is going to be 7.813. So when I come here, I can go ahead and type in contour, enter. My base point is going to be down here at the bottom, but I need my contour to be going straight up and down in the Z direction. So let's back out in either the front or the right side view so that we're going straight up and down. And it's going to be 7.813 feet. And I'll go ahead and hit enter. And it will then divide up my piece of terrain. So like I said, this was a particularly steep piece of terrain. So my steps are going to be, there's going to be a lot of steps as part of it because it's a really steep piece of terrain. So I have that established, and actually I should have put those on their own layer. Let's put them over here on layer 4. Let me change object layer. Let's rename layer 4. We'll call this contours. Let's call this topo lines. There we go. So I could actually make that active and turn off the terrain altogether, and we'd be left with just our topo lines. Now remember, that 7.813 feet is because we're at 1 to 50 scale. So when we scale this down and eventually cut it out on a laser cutter or have the file, each one of these steps will be the thickness of a piece of cardboard. So now it's time to actually start drawing the sides. And as I did last class, there's 2 different methods for doing that. The first one would be to create a series of points. So I'll use the multiple points tool, and I'll create a point on the end of each one of these lines. Like that. After I've created all those points, I'll select those points, and I'm going to do that by typing SELPT to select point. It'll select all the points for me. I could go through and hold shift and select them all. I could draw a box and select them all, just different methods. And then we'll do a rotate 3D. So I'm going to go to transform, rotate 3D. I'll use the bottom point, and I'll use my axes, in this case it's the y-axis, to fold all of these points down. And there they are. Now I can go ahead on a new layer, we'll call this layer 5, sides. I can actually use my polyline tool and I can start to draw. I need to make sure that I'm snapping to points here. And I can start to draw the steps. So I can say, okay, there's my first point. We'll come over. There's my snap to perpendicular. I do have my perpendicular snap on. So I'm using smart tracking to get those perpendicular lines. And then I'm drawing each one of these steps. Almost done. And obviously I would keep going with the rest of the steps on the side, but actually this is all the steps. So at this point, I'll select those points again, and I'll select my line. There it is. And we'll do that rotate 3D again. So I'll go to transform and then rotate 3D. Start at the same base point, same axis of rotation, and we'll fold it from being flat to being up vertically. And now I have my steps vertical. So that's one way of doing it. The other way of doing it, and I talked about this last time, is to change the drawing plane, the Seaplane, which is represented by our little grid here, into being vertical so that you can actually draw just on the side as we're creating those steps. So first thing I tend to do is I tend to make the grid much bigger. So let's go over here down at the bottom where it says Grid Snap. I'll right click on it and go to Settings. You can also access this by going to the Tools menu and then Options. And then under Grid here, I'm going to say we want 2,000 lines. We want our minor grids to be every 12 inches. So it would be every foot. And we want our major grids every, let's see, let's go every 10 minor grids. And then we'll go ahead and say OK. And when I do that, you can see that our grid just got a lot bigger. And so now that that's so much bigger, we can use that to kind of visualize our drawing plane. So right now it's flat. We're going to change that C-plane so it's on the side of this. Actually, I'm going to do this side over here. Okay. So what I'll do is I'll come up to the little triangle next to where it says perspective, and I'll go to set C-plane 3 points. I'll pick the lowest most point right there. I'll pick what I want my x-axis to be. There it is. And now I want to be going straight up and down. Well, I can't do that in the perspective view, so I have to come back to one of these front or side views so that I can go straight up and down. And now in the perspective view, my drawing plane is now vertical along that side. So the advantage here is that all I need to do is go ahead and start drawing. So I'll start with my line. I'll start down here. We'll come over. We'll snap. We'll come up. And we'll draw it right in this plane. So this is definitely, in my opinion, an easier strategy for working on the sides because it doesn't involve, it doesn't involve all of the rotations that the other strategy does, but it's a little bit harder to understand it can be a little bit harder to understand kind of the mechanics of the fact that we're changing the drawing plane as we go forward. So I have those steps drawn. At this point, I'm going to switch files and come back to the one that I was working on last class here, because I've already drawn a lot of the sides. And in the interest of time and you guys watching me lecture and whatever, I think it's a little bit easier for me to continue working on this side. What I told you last time was to make sure that you've drawn the sides, but to not worry about the corners so much. So it looks like I still have one more side along the front here. So this is a good opportunity to practice changing the seaplane. So I'll go back up to my little triangle by perspective. I'll go to set seaplane, and because I want to change it, I'm going to go back to world top first. It's always a good strategy to reset to world top, and then we'll create a new seaplane. So I'll go to set seaplane, 3 points. I'll choose this point right here. We want to make sure, let me turn on ortho. We're perfectly in line along that axis. And then we want it to be going straight up and down. There it is. And now we can see that plane that's along that edge. So let's go ahead and finish the steps on this side. And a lot of this is manipulation, so you can kind of see what's happening here. So we'll start right there, and we'll start coming down there. There. Now, this is a point where I got to the bottom. So when you find this happening, right, if I were to go straight across, that just doesn't seem right. I need a step here. So we need to go down by the distance of my contour interval. So in that case, last class, if we jump back over here, it was a different scale. It was 1 to 500. So I come over here to the 78.125 feet. And we go ahead and we go down by 78.125 feet. There it is. And I want to be going straight down. Then I'd come over and then go back up. So I have a step that comes down and over. So when you get to the bottom of one of these steps, you're always going down an extra step and then coming back up. When we reverse and we start coming up here to the top, we get to the point, we've done our step, there's our step, we come straight across, and then we're going to start going back down. So it looks like I have a tiny little piece over here in the corner. So we'll do that, and I'll finish. So now I have the bulk of my sides done, and this is what I was asking you guys to do last class. We need to think through, how do we finish off the corners? So this is very much using the same kinds of principles that we talked about. So let's look at this corner first. Well, in this corner, we get to kind of, we're going up along here, we're going up along here. So what we need to do is just create a line where these two pieces would intersect. They're at the same level. So we'll start by creating a line that's long, and then we'll come over, snap to this end, come over perpendicular, and those two then meet at that corner. I'll need to do a trim. And we use that as the cutting object. And there's our first corner. Right there. Let's look at our next corner. We'll come around here. So this one, we're coming down on this side and we're coming down on this side. We get to a contour, so we need to go down again on both of these and then meet in the corner. So I'll start here and we'll go down by the 78.125 feet. There it is. And then we need to come over, and I'll leave that one long. This point also needs to go down by 78.125 feet. Enter. There it is. And we'll come over to perpendicular. Oops, let me go straight down. There it is. And we'll come over until we hit perpendicular right there. Now we can trim it. So I'll select this piece. We'll type trim. And we'll trim that piece off. So we've done the top corner here. We've done the bottom corner here. We come up and over. All of that looks good. We get to this corner. So this corner has a little itty bitty contour in the corner, like a tiny one. Okay. And that tiny little one, in all honesty, if we were to laser cut this, this would just get burned up into smoke. So it's not really advantageous for us to do anything. Technically speaking, it would go down and over. This would go down and over, and they'd meet at the corner. But because this is so small, we can safely just get rid of it. because it would burn up when we went to make the physical model. So I'm going to go ahead and just hit the delete key or type delete. It'll go away. And then I can actually just join those two pieces together. And I can do that using a fillet. So I'll type in fillet. My radius here needs to be 0, so they come at a nice sharp corner. And I'll connect this and this at a point in space. And that's because that little piece was just too small. Okay, then we come over to this corner. Looks like I haven't finished in this corner. So I really need to reset my Seaplane so it's in this plane so I can work on finishing it. So I'll go to that little downward facing arrow. I'll go to Set Seaplane World Top. And then we'll go back to my Set Seaplane 3 points. We'll start right there at that point. There's our first axis. Our second axis is going to be going straight up and down. Remember, I'm not snapping to anything. And there it is. And then we can go ahead and with our polyline tool, start here, draw this next step down, and come to here. So that gives us that point. So here's another example where we have a tiny little contour in the corner. Now maybe this one's big enough not to get burned up. If it was, we'd be going down the 78.125 feet. Then we come over. And then we come back up, which is convenient because this line meets right at the corner. The alternative to that would be that we could go ahead and just delete that little piece, just like we did on the other side. So we could take this, we could delete it, and then we could use a fillet to connect this piece and that piece with a radius of 0. That then allows us to get rid of that little piece. So we're making a few modifications, and that's just because in the scale of our model, it's not really going to make a big difference that we've done that. So at this point, I have all of the corners done. I'm going to go do a file and then a save. Perfect. And now that I have that done, I need to start thinking about what do the sides look like. So if I was going to create what the side looked like, I would need to go ahead and draw the side. So we already have the Seaplane for this side. So let's go ahead and draw a side. So we'll start here and we'll come down. We want it to be a little bit taller than, or a little bit longer than where our lowest point is. So that's our lowest point. We want to go down a little bit more. So we'll go down to about there. And then we'll draw over. And that is arbitrary. We're just deciding where it would go. And then we'll come back up. So this plus this plus that is going to be a side. So let's go ahead and join it together. That's our first side. Now we want to do this next side. So let's reset our Seaplane. I'll go here. I'll go to Set Seaplane World Top. So we reset it. Then we'll go here. We'll go to Set Seaplane 3 points. We'll start right here. And then we want to go vertical. Now, the advantage here is I can actually snap to that little step because I already have it. And so once again, I'll come back to my polyline. I'll start at this corner. I'll go down to where my height was before. I'll come over. I'll reference that point right there till it's perpendicular. There it is. And we'll come back up and join right there. I'll hit enter. So this plus that is now the next side. So let's go ahead and type join. So I have a side here. I have a side here. We need to create a side at the back end here. So I'll come back. I'll go to Set Seaplane World Top. We'll go back here to Set Seaplane 3 points. We'll go out, and then we'll go straight up and down. There it is. And same process. I'll come over here to the corner. I'll draw a line down. We'll draw a line over till it meets this point. There it is, and back up. And then I'll take this line plus that step, plus that step, plus that step, plus that piece, and we'll go ahead and join that. So now I have 3 of the sides. That leaves me with the last side. Well, I actually have all I need to create that last side. I don't have to change the seaplane again. I can merely start and trace down to that point, come over to that point and back up. That gives me that piece of the side. And then I'll hold down Shift and select that part, and that part. And then I'll go ahead and type join. So I have 4 sides that are all closed curves, which is exactly what I need. So I've created all the steps. I have all of the contours. Now it's time to start thinking about how does this model end up being a 3-dimensional, or excuse me, something that we can actually cut out. So let's go ahead and reset the seaplane. I'll go back to set seaplane. We'll go to world top. Here we go. And so now I want to think about how do these become a flat object? Well, first off, we need to take all of the contours and we need to get them flat. So we'll create a surface at the bottom here. There's a surface. And we'll use that to project all of those lines. So I'll go over to my layers and I'm going to select the topo lines. I'm going to switch my view into the top view. Remember, it has to be in the top view. And for the ease of seeing this, I'll go back to a wireframe mode. There it is. And I'm going to type project, or go to curve from objects, project. And I'm going to project those flat onto this surface. Realistically, I should have my own layer for this. So let's go ahead and create a new layer. I'll make that active, and then we'll go ahead and hit enter. That then takes all of my topo lines and it puts them flat on the ground. So at this point, we can go ahead and delete this surface. We don't need that anymore. We'll type delete. There it is. And we can turn off the topo lines layer because we don't need those. And let's rename this layer 1 into laser cut. And then let's keep working with it. So in order to cut these, we're going to have to fold the sides down. So I'll take each side and I'll use a rotate 3D. Our axis of rotation will be along the bottom here. And we'll take it from being vertical to being flat. Repeat the process. I'll right click to repeat. Our axis of rotation is right down there at the bottom. And we'll fold that flat. We'll come back to this piece. I'll right click to repeat our axis of rotation, and we'll fold that flat. Last one is right here. We'll right click to repeat. My axis of rotation is right there, and we'll fold that piece flat. So I've now, kind of like when you have a cube and you unfold it, I've essentially done that. I have my contours and I have my sides and they've all been folded flat. We do want to make sure that the folds that go down are always the same. So they're all going the same direction. They're all folding out. Okay, so I have those pieces. Now that I have those pieces, let's go ahead and take them all and let's put them on the laser cut layer. So I'll right click and say change object layer. And now that I've done that, we need to actually scale it down to the size that we're going to laser cut. So I'll take my objects. Remember, we knew that this was going to be at, in this case, it was 1 to 500 scale, but we also knew that the distance from here to here would be 17 inches. So we can actually do a scale, and this is a full regular scale. So it's not like a scale 2D or something like that. It's just scale. And we'll say that the distance from here to there should actually be 17 inches. We'll put the quotation mark in and hit enter. I think it's really, really small. So let's zoom, select it on it. And let's go ahead and move this point to be at 0, 0. So we'll go 0, 0, and then zoom selected. So now this is at the scale of the physical model that we're going to be creating, rather than at full scale, which it just was. So we've shrunk that down. And now we have to think about actually laser cutting it. So when we start to do that, we're going to need 2 sublayers. So we have a laser cut layer. We'll create a sublayer for cut. And then on the laser cut layer here, we'll create another sublayer, and this is going to be called engrave. And we're going to use those to our advantage. The cut, because of how the laser cutter works, we need to change the color of the layer. So right now it's set at black. We need to change the color to red. And we'll go ahead and say OK. And the engrave, we're going to change the color to blue. We'll say OK. So I have a laser cut layer. I have a red layer for cut. I have a blue layer for engrave. All of these sides are going to be cut out. So we can change those right now onto the cut layer. We'll right click and we'll change object layer. And those are now on the cut layer. Furthermore, we need to be able to place them on the laser cutter bed. So we need some guides for ourselves. And the laser cutter bed is a rectangle, and it's 12 inches by 17 inches. So I'm going to create a few of those. I'll say at 24 inches, comma, 12 inches. It's 12 by 24. So that's that laser cutter bed. We'll copy it again. And you may need 3 or 4, depending on the size of your topo. I'm pretty sure I can fit this on just 3 sheets. So at this point, I could start moving these objects onto those rectangles. So we could zoom in here on the top view. Sometimes it's easier to do it that way. And I could type move, and I could say, OK, well, this one will fit on this. Let's move it over a little bit. There it is. Let's take this one. And we can move it over here, like that. This one, for example, I can move it up, and we can move it over. Now, it doesn't really matter. I could try to fit all of these on. What I don't want is I don't want anything to overlap. So let's take this one. Let's move it. Like that. I can rotate these if I want, but I think I can make them fit. So let's continue moving these around just a little bit. Not bad. OK, they all fit. So that's on one sheet. That would cut out just the sides for us. Now it comes down to this part. I don't need these points anymore. Let me type SELPT to select points. And then I'll go ahead and delete those. OK, so I have the topo lines. Well, I'm obviously going to have to cut around the topo lines. So let's draw a rectangle around the topo lines. So we'll start there, and we'll end right there, because we're going to have to cut those out. And that should be on the cut layer. Like that. So we know we're going to cut that out. Furthermore, I could take this and I could move it up onto the laser cutter. One of these. Let me turn off ortho here for a second. Stop snapping to say things. And disable my snaps. And there it is. And I could also copy it, because I'm going to need a second copy. So we'll put one more right up here. And you say, well, wait a minute. Why do I need 2 copies? Well, if we were to take this and we were to cut every one of these little pieces out, we'd have no way of kind of aligning them and making sure that they glue together. If you remember back to the video that I had shared on here, maybe some of you watched it. I thought it's on the handout. Let's see here. Right, this one. I don't want it to play audio, so let's mute that for a second. When we come in here, all right, let me make that bigger here for a second. Okay, so there's the sides that we just saw. But when we get to the actual pieces that are stacking here, I have these individual pieces. See if I can see it right there, where we want to be able to stack them together. So one piece needs to overlap the next piece. So that's where these come into play. So let me escape out of that for a second. We're creating overlaps, and we'll do that by starting at a particular point and selecting every other line. So on this one, I'll select the first point, I'll hold down Shift, and I'll work my way up the contour and select every other line. Okay, when you get to a place where that one would continue around, let's see, that would be selected, that would be selected, and then we'd work our way up here. Oops, that was wrong. And of course, I'm on a Mac, so I can't use the Control key to deselect. Yep, it's going to not work for me. So let me start again, sorry. There, hold down Shift. Remote desktop issues. Okay, good. We'll pick that one, we'll pick that one. And we'll pick that one, that one. And that one. So you can see I'm kind of working this. Let's see, this would be not selected. Okay, so I have them. Oh, I have to do these too. Let me pick that one. I'll take all of those and I'll put those on the cut layer. So remember, it's every other one. I'll right click and say change object layer. Those are now all on the cut layer. The remaining ones, so these ones, all need to be on the engrave layer. And what engrave means is it'll put a small little line on it to help us identify and line up these pieces. So we'll select the rest. And those will all be put on the engrave layer, like that. So I end up with red and blue lines with a red border. Now I do the exact opposite on this one so that we can, it's kind of like shuffling a deck of cards. So this time we'll start with blue here because it's red down here, and we'll alternate. So this is going to be all engrave ones. So let me go through and pick these. All right, that's correct. We'll come over to the engrave layer, we'll right click and change object layer. So compared to down here, it's the exact opposite. So whatever's red on this one should be blue on this one and vice versa. So let me select the remainder here. These are all going to be red. And so when you guys have time, I would encourage you to watch that assembly video because it'll help clarify what's going on. There we go. And I'll right click on the cut layer and I'll say change object layer. And there it is. So what I end up with here is I end up with two exactly the same cutouts, but with alternating colors. So anything that's red down here is blue up here and vice versa. And it looks like I missed this, so this one should have been red. There you go. Sometimes we have those little mistakes. Okay, so I have those set up. We're ready to do the laser cut if we were going to do it. The only thing that we haven't taken into account yet is the fact that there is thickness of the cardboard. And because of that thickness, if we were really to glue the sides together, there's going to be an overlap in the cardboard. And you can see it, and I may not have done it in this video, but you can see it kind of in the beginning of this video as I'm starting to glue those two sides together. We want to take a little bit off each side. So we just want to make sure we're either picking the long sides or the short sides, and then we can come in here and we're going to take the thickness of the cardboard off. So it would be 5/32 of an inch. So I'll do it on the short sides. I'll start there. We'll come over here by 5/32. And we'll draw that in. We'll start here and we'll go 5/32. And we'll draw that in. Is this absolutely critical? Am I going to measure it for you? No, because we're not making this physically this semester. However, if you were to go in and try out the laser cutter on your own and build this, which of course I would encourage you to do if you have time because you'll learn a lot in the process, if you didn't take this into account, you'd have to trim this after the fact. So let's go ahead and go into trim. We'll use these as our cutting objects. There we go. And I'm going to trim off those pieces there. And then obviously those 4 pieces need to be put on a cutting layer. So right click over here on cut, and we'll change object layer. So now that I've done that, I have all the pieces I need to make this laser cut file. So in terms of what you're turning in, what we need is we need a screen capture showing these red and blue lines. So I'll zoom in. We could do a zoom and then actually do a window so that these fill the screen. And then we'll go in and capture this. So I'll go to capture to file, and this will save a JPEG version for me. We'll go ahead and say OK, and we'll put it into my folder here, and we'll click on save. That's what you'll turn in for me for exercise 213. It's also what you're going to turn in as part of your assignment 202. So I can visually see and verify, because I don't want to go in and open everybody's AutoCAD file. I want to make sure that you have this and that the red and blue lines are established correctly. Once this is done, in order to actually perform the laser cut, we want to select these objects, and we want to go to File and then Export Selected. And instead of exporting a Rhino file, we're going to export an AutoCAD file. That's what the laser cutters can read to do the cutting. So we'll export an AutoCAD file. We'll call this terrain or something like that. Well, let's call it laser cut. And then we'll go into my folder for today, and we'll save this. I should probably add a fall 2022. There it is. And we'll go ahead and click save. Yeah, you had a question.
Yeah, I was wondering, would this be like the same process for like CNC?
It's similar. The difference between CNC is that we'd be like, in this case, it's just a laser cut and we're cutting it out. In a CNC, when we're machining something, we have to create tool paths, and rather than having, let's in hypothetical terms, an infinitely thin laser that's cutting out along the line, when you go and CNC something, you have a bit that's in the CNC, and that bit has an actual thickness to it. It's not a beam of laser light, it's something that's thick. So let's say, for example, it's a 1/4 of an inch thick. Well, you have to, with these, create what's called a tool path that tells the CNC machine, do you want to cut on the inside or the outside of this line, or in the center of the line? So there's a little bit more involved in setting up that file. This, you could pretty much like drop it in and say, cut it out, and it'll cut it out for you. On a CNC file, you'd have to spend a little more time on the toolpath, making sure that it was cutting the way you wanted it to cut. But yes, it's very, very similar. So I'm going to save this as an AutoCAD file. There are some options for save. I usually do the polylines, the 2007 polylines. It's pretty generic, but it should keep the lines together, which is nice when we cut them. I'll say OK there, and I'll click on save. This will create the AutoCAD file that I need to be able to perform the laser cut itself. When you turn in your 213, I just need the JPEG. When you turn in your assignment 202, which is still a ways out, but when you turn that in, I need the JPEG, but I also need the AutoCAD file, because I want to verify that you were able to create the AutoCAD file as part of this assignment. Okay? So I know I went a couple minutes long today, but at the same time, this was all the way through the process. And I think it's important for you guys to get it all the way through in one lecture, even though we broke it down into steps along the way. Okay? So I'm going to go ahead and stop my share, and I'll stick around today if anybody has any questions. I know there's always issues with how the corners come together. So we'll use check-in time today to primarily cover that. But if you have other questions, of course, stick around and we'll cover those as well. Some of you came on Monday. If you feel like you have issues and you want to come back today, there's nothing wrong with that either. So let's go ahead and take about a 10-minute break. We'll come back at 12:25 because I went a little bit long today, and we'll go from there. All right. Thanks.